Look at all the people coming in. Great. Just waiting to get to 100. 99, 100. There we go. So let's get started. Good afternoon, everybody. Welcome to the EOcafe. It's great to see more and more people coming along. We thought last time that we had a record number of registrations, but we've broken that record this time. So we'll see how many people come in, but over 300 people have registered for this EOcafe, which is really great. And I use that as an opportunity also to remind you, if you have any topics that you'd like to see us discuss in the cafe, then just drop us a line, let us know what would be of interest to you. So just a reminder for anyone new, the EOcafe is meant to be just a sort of a casual meeting or get together around a coffee. We have some guests. I will talk with those guests around the subject, and you're just here to listen in. And then after a certain time, then you can join in. So if you have any questions, please put them in the chat, and at the appropriate time, I'll give you the floor and ask you to pose your question. General rules, please keep microphones off unless you're given the floor to talk, but please feel free to keep your cameras on. It's nice to be able to see people and to have the visual images, which we've, I guess, become used to now. But up to you. If you wish to use your camera, if you wish to hide behind a blank screen, that's also fine. But up to you. So today's talk is on the subject of artificial intelligence and its use for generating EO services and proposing EO data. Goodness me, it's a long time since I wore a suit and tie. Look at that picture. We have two guests, Anna-Katrine Debian from Space Tech Partners, and Anna-Katrine is the project manager for the AI for EO project with Space Tech, and Nicolas Longepay, who is with the European Space Agency PhilAb, and used to is an EO data scientist. Nicolas recently joined ESA. I see that previously he was with CLS, member of ERSC, and before that, Nicolas, I see you were in JAXA. So that was an interesting experience, I imagine.
Sure.
Okay, so artificial intelligence, machine learning, deep learning, all address the subject of big data, of automatic processing of data, and normally very high volumes of data. It's not a subject I know a great deal about, so I'm really interested to learn more today. And as I say, if you have questions, please put them into the chat and we'll come to those later. Artificial intelligence is often linked with message coming through. Artificial intelligence is often linked with another of these terms, the Internet of Things, largely because of the large volumes of data, and especially data which is a bit noisy and trying to extract information out of noise. One example of that coming from a project I've been involved with a little bit, the Better project, for monitoring seismic activity to try to look at improving earthquake prediction, managing of earthquakes. We're looking at setting up network of stress gauges, of microphones, of in-ground sensors connected to social media, and using all that data to try to improve the management of earthquakes through prediction or monitoring of seismic activity. That was presented in the recent Big Data and AI workshop that took place in November. The commission organized it. Another example I've recently come across for monitoring woodlands, where chainsaws are being equipped with microphones and GNSS positioning sensors. So the activity of the chainsaw can be deduced from duration of its activity, the depth of cut, the solidity of the cut, in order to monitor forest clearings. That, of course, brings ethical issues. and I wonder quite how they will either regulate or motivate the chainsaw owners to participate to this sort of activity. But it's an example of where technology is getting ahead. But is AI ready to be deployed widely? I'm not sure how good this example is, but it was a striking one in The Guardian yesterday, reporting on an MIT article where algorithms were being used to complete pictures, and they put torso pictures of a man or a woman. So they cut the head off and had the picture of the person, and the algorithms were then completing the picture, and they completed the picture of men with a suit, something like 50% of the time, and 50% of the time the women were completed with in bikini. So there you have so ethical issues associated with the use of AI. But I imagine these will be overcome. But hopefully our guests can talk a little bit about that. So to understand more, and particularly to look at how it can interact with Earth observation, ESA have launched a project, AI for EO. So maybe Nicola, I can ask you straight from the beginning, why have you launched this project? What's the background to it in relation to the Phi Lab, and how's it going to work? Nicola, please.
Oh, thank you very much. Well, just to introduce myself first, so I'm Nicolas JP. I'm with the Phi Lab, which is part of the Directorate for Earth Observation Program, so at the European Space Agency. So we belong to the Future System Department. And so as you may know, ESA develops Earth Observation Program at European level. We build and operate satellites. We are in charge of the operation of several Earth observation mission, Copernicus, for sure, Copernicus Sentinel-1, 2, and up to 5P now. And we do have also the Earth Explorer, which is more dedicated to, let's say, research mission to address, for example, key scientific challenge by the Earth science community. So we have the Gochi, the SMOS, the Swarm, Flex, that will be launched in 2023. So at the Phi Lab, basically, which is part of the Future System Department, we aim to fuse all type of information. I mean, ranging from the Copernicus mission, but also Earth Explorer. Why not high altitude pseudo satellite, drones, nanosats, and not to forget, for example, social media information. So thanks to AI in general, we are talking about prediction, detection, classification, big data analytics, super resolution, emulation, whatsoever. So we take all the data set coming from this satellite, and we want to get some insights on the planet Earth using AI. And so basically, at the Phi Lab, just to introduce a little bit what is Phi Lab, there are two branches at the Phi Lab. The first one is about the Explore Office, where we try to apply transformative technology to Earth observation. So basically AI and deep learning. And we try to apply that for climate change and so on. A little bit of Phi Lab again is that we are about 25 people. It's pretty new at ESA because it was built in 2018, so 3 years ago, two and a half ago. We're about 25 members. And so again, at the Explore Office, we aim to fuse all kinds of information. And so we do support a wide range of activities from the whole pipeline on the use of AI for Earth observation, from data preparation up to the organization of challenge. And also one important activity that we have is to try to foster the use of AI within the community, bridge the gap in between the deep learning guys and EO scientists. And this is a little bit the goal of this AI for EO, is really to bridge the gap in between the communities, make the deep learning guys working on Earth observation data and all the challenge that humanity will face in the future. So this is why we do this project. It's all about connecting people. It's about having new solution. We know that deep learning and AI in general is a very fast-moving topic, and we want the best people and the best talented guy to work on our challenge, which is about planet Earth and Earth observation data. And just to finish about the presentation of the PhilLab, there is also another branch which is called the Invest Office, and within the Invest, actually, we have a program called Incube. Incube stands for investing in industrial innovation. So it's a kind of public and private partnership co-funding program run by the PhilLab. So we aim to develop innovative and commercially viable product and services. So we have some funds. So I will put in the chat the link of this program. Please, for those who are SME or companies in Europe, you may apply for this, and it can be a great opportunity for you if the chat is working. Yes, right. So here it is. So AI for EO is really for connecting people all together, deploying EO, and for the goods and for planet Earth, basically.
Okay, I think maybe we come back to Incube a little bit later, because I know there are opportunities in there related to AI and
Sure.
onboard hardware as an example. But in order to understand a little bit more about the project, I mean, we as ERSC certainly look to bring together the EO community and the EO services companies, the commercial community, the AI community. What does that look like? What's the project going to do to help bring these two communities together? Anna-Katrine, perhaps you could say a few words about that.
Thank you. One of our main aims of this project is indeed to bring together those two communities so that they can benefit from each other. I think the AI community is very diverse. You have AI in nowadays almost every field in finance, in medicine, and well, in just about anything. It's starting to emerge as well in Earth observation, but to really bring together those two communities and have Earth observation experts benefit from what AI experts know and do in their fields, but then apply it to Earth observation challenges, which could be a little bit more complex. Because a satellite image is never just a picture from a cat or a dog where you run some computer vision on and say, okay, this is a cat, this is a dog. There are more, you can extract more physical parameters from it. And so there's knowledge in both communities that the other community doesn't have. To bring them together, at the moment, we're also building, of course, as well on the experience of the PhilLab, who has been building partnerships with AI communities, scientific communities in Europe. The CLARE initiative, for example, is to then really build up relationships with bigger initiatives like CLARE, like the AI for EU initiative, Horizon 2020 project. And all of those universities that work in AI to expose them to a set of Earth observation challenges and stimulate them to participate in it. I think within this community, you will have a lot more people, developers who are used to these online machine learning competitions. You have like Kaggle, for example, has been around already for a few years and is also fairly popular with developers. So what we're doing now is setting up a platform that's very specifically focused on Earth observation, but that brings this how do you call it, the popularity of doing a challenge and being part of a developer community to that.
Somebody's having fun.
It's very funny.
Microphones off, please.
For the moment, so we've started back in August, and we've been building mostly communication channels on Twitter, reaching out to the right people, connecting directly with those bigger AI initiatives that already exists in Europe, to inform them about the project, to partner up with them, and then also by the challenges that we launch. We choose them because it's Earth observation people that say, yes, this is something that we're looking into, and we think AI could be of benefit to this challenge. Like our very first challenge that we launched just at the beginning of this week came from ECMWF. As you've seen in the past weeks, they're also really focusing on implementing AI, machine learning into their products. And so this is one that was suggested by them. And we're hoping that that both AI and EO people will be interested in it and will participate.
Okay, let's come back to that a little bit later, but let me wind you back a little bit, because from what you're saying, is the AI community then really a research community, or is it is it industrial community? What are the component parts? What are the sort of practitioners a part of it?
I think it's both. Within research, you start to see a lot of universities that have either AI departments or are integrating AI into their various departments. And then you start to have companies that are developing AI models for clients for particular products or services. So it's a very broad ecosystem, and we would have to also really then dig deeper into who is it that we best target and cooperate with.
Okay. I'm always a little bit, because you made the point that it applies in so many different domains. How transversal is it, Nicola? How can you, does it easily map across different domains, or is it something where there's a strong technical flavor, let's call it that, to Earth observation and dealing with Earth observational problems? What's the transversality of this?
Well, it's true that within the AI, so AI is this is the capabilities for a machine to assimilate information, let's say, and to perform tasks that can be made by human intelligence, let's say. So having said that, I mean, so it concerns many things. It concerns recognizing the object, sounds. It's about language. It's about learning from environments. So from this, I mean, recognizing objects within an image that can be quite well fitted to the Earth observation, because we want to do segmentation. So basically, what we do in the Earth observation domain is we mostly use computer vision techniques inherited from the deep learning. It's true that for now, there are some branch of AI that we don't use within the AI sector, within the AO sectors. Is about natural language processing. We're able to do that, and we're able to query, for example, from text, a large archive of Earth observation data. I'm not sure about that. There is also this aspect about learning from the environment, and in that frame you have this reinforcement learning, and where you have an agent able to move, let's say, in unknown environments. And this is some kind of technique that we don't apply for now in the observation community. So basically, what we use computer vision. We use CNN, which is deep learning, so it's a stack, or let's say, of neural networks that are very good for segmentation and detection of objects. It's worked very well on very high resolution optical imagery. It works also on SAR. It's worked on many things. We start to use also recurrent neural network or LSTM stuff, which is adapted to time series analysis. We do use also GAN, which is generative adversarial network, for example, for synthesizing new images or mimicking. Let's say that you want to combine a fluid map with an optical image, then you may create a fake inundated Sentinel-2 images. This is some kind of stuff that you can do with GAN, and so it's mostly based on computer vision techniques. So for now, I mean, we don't use all the techniques that are available. We use, let's say, a small part of them.
Okay, there's a few technical terms and acronyms that are coming out.
Yeah,
there,
sorry about that.
No, let's leave. If people want to ask, they can ask it in the chat. But one thing I wanted to just press a little bit further, because I've been reading about sort of moving from supervised to unsupervised learning, which also seems to somehow fit strongly in artificial intelligence, unsupervised learning. What's the sort of view on that from the perspective of Earth observation?
For now, we mostly use supervised techniques. I mean,
okay.
we need to have database. We need to have a label associated to this database. And for now, the research activities, I will say, on the field on unsupervised, be able really to extract some content without any model to learn from is something that I mean, it's very preliminary result that we have within the observation community. It's true that, and this is a matter since the collection of ground in situ data is very challenging. We need to have it, I mean, in a quantitative matter, but also qualitatively. This is why combining Earth observation data with model can be also a solution. Try to ingest some prior information from physics and not from ground truths that we don't have sometimes because it's remote areas and so on. An idea also to combine information is to use social media information, because sometimes you have some information. Let's take that you are in a cafe and you take a picture and you say, this is I am seated on a cafe and we have a building made on these materials and so on. So that gives us some kind of information. And I'm not saying that we are in this stage of processing, but this is some way also to collect some information and to get it against the Earth observation data that we have, for sure, because we have an overwhelming amount of Earth observation data. This is not what is missing; it's really the ground truth. Mm-hmm. And regarding to that, there is an ongoing nice initiative that we have with ESA with a partner in the Netherlands. They make gamification to create ground truth, let's say. So they created a game for anybody, and it's work on smartphone, for example. And then you are able, I mean, everybody is able to navigate within the game, let's say, and do his own data labeling. And then this data labeling can be used for deep learning training. So this is some new way to also collect in situ information, which is very crucial for deep learning, because we need supervised learning.
Yeah. Okay. Let's come back to the project. There are some sort of more general questions starting to appear as well. But Anna-Katrine, so firstly, the project is about linking the communities and doing things to help the communities find each other, find partners, find expertise. Is there a sort of best practice role in there that is being followed? How are you? Is it unsupervised in that people are left to find their own partners? So there's a sort of a cloud-like approach, or are there activities which will sort of direct people in certain directions and try to help them find somebody with an expertise in a particular type of domain?
So at the moment we're not, or at least not yet, trying to really bring together those two communities at a large scale. We're building that community online a little bit to inform both of them about what's happening in Earth observation, what's happening in AI, through our Twitter channel. But for instance, now for the challenge itself, we do give people the possibility to perhaps say, I'm looking for, we're a bunch of AI experts, but we need an Earth observation expert. Is there a lone Earth observation expert that wants to participate in the challenge?
So the first step is really about building awareness.
Yes.
It's trying to help build awareness of what's possible.
Mm-hmm.
Okay, and tell us a bit more about the challenge. You mentioned that it was sort of introduced by ECMWF.
Mm-hmm.
What is the challenge precisely, and how can companies get involved in it?
So the challenge right now is related to air quality. There are a lot of free and open data sets available, for instance, from Copernicus, that give information about several air quality parameters. You have the Copernicus Atmosphere Monitoring Service, which is very renowned. You have the Sentinel-5P satellite imagery. But those give data on a very coarse resolution. While if you want to use it for monitoring, the impact on health of citizens, you usually, or within cities, you usually need it at a much higher resolution. And there are techniques available. There's modeling. There are integration with ground sensors. But that's not always possible because of the lack of those sensors, or the modeling itself can be extremely expensive. And so what we've just launched is a challenge saying, help us or find a solution for downscaling air quality parameters to a more usable resolution of about 1 by 1 kilometer using AI techniques. And the way companies can get involved is, of course, by participating in the challenge. The challenge is open to anyone, to any team. And we're hoping to get a lot of different teams trying out the challenge and finding a good solution. And perhaps one of the things that is very important as a company, if you participate, your IP will stay with you. So the idea is we want to see something being developed, but we won't be taking your solution and then publishing it online or using it ourselves. For us, it's really about stimulating people to think about this challenge and doing something about it.
Okay, and what do companies need to do to join the challenge?
You can go to AI4EO.eu and register. The platform has been open since Monday, so everyone very welcome.
Okay, so before turning to questions, maybe we just come back very quickly to the Incubed activity, Nicola, because that does have a direct relevance, I think, for the AI activity as well. How can companies with ideas associated with artificial intelligence, about whether it's processing data, well, how can they get involved in Incubed?
Well,
how can that help them?
The program is made to. The program is very easy to access. So please have a look at the website, and it's let's say quite easy to apply in the sense that it's a by incremental step. Let's say that at first you just are required to provide a pitch. To be a 10 or 15-minute speech, and then you will be asked for a short proposal. Then there will be a second stage proposal. So it's very easy. I mean, there's no selling price. It should be co-funded and also validated by your national delegates. Not all countries in Europe participate to this program, so you may check on the website and have a look on the list of the member states who participate to that. But it's quite let's say, easy to apply for, and also the time for the answer is very short, or let's say shorter than the one that you are maybe use with standard ESA proposal.
This was
It can be very convenient for you.
Yeah. Okay. I mean this was a
and
subject.
it's actually yeah. Go ahead. Sorry.
No, finish, please.
No. Definitely all the topics are of interest. I mean, we covered. I mean, from ground station to services, from building satellites. I mean, it's very open to all Earth observation domains, I would say. So I guess that all the members of your community should be interested in.
Yeah, I think so. And we have talked about it before. I'm assuming that there are probably some people who are not so familiar with it. We're getting a few questions, so let's bring some other people into the conversation. We can come back on specific points later if we have time. So Benedict Vierneisel has a question around the PhilLab. Benedict.
Yes, hi. Jeff, we talked recently on the phone. Yeah, my question was if the PhilLab addresses the high demand of test data sets for the EO community. So as people want to train their AI algorithms, they need this test data to further advance in this sector, I think, at least. And this is my experience from a lot of workshops and stuff. Can you elaborate on this, maybe?
So sorry, I don't really understand your question. Do we provide test data for AI topics?
Yes, yeah. Are you planning to address this demand of test data?
Well, I'm not sure. I'm not sure to really understand your question. Is for sure is that we are engaged in a variety of topics. I mean, for really a wide range of application, from oceanography to land to cluster and so on. And for each one of these topics, and each of the project that we led with the different consortium, we integrate that part. I mean, there are always some kind of campaign to validate the algorithms and so on. And usually all the data and all the project with these the data can be shared or made on open basis. So this is something that we are willing to do at least. And I think that for every action that we have in the different fields, there are some data set that exist. I'm not saying that is the best, but so I don't know. I'm not sure that it's answer to your question, but maybe you can elaborate more on what you are thinking about test data. And
Shinichi has a similar question. Shinichi from JAXA. JAXA. I don't know if you want to amplify that, Shinichi, or was the question covered by, or your answer covered by the previous question? So I know it's very late there, or very early. Shinichi, you still with us? Okay, let's move on. Dietrich, about limitations of AI for EO data. Where are the limitations, Dietrich? Hello, Dietrich.
Yeah, it is my question.
He is there.
Yeah, I'm here. It's not too late here in Zurich. Yeah, it is my question because I think from the data I'm working with, remote sensing data and agricultural application, what I find is that I have a lot of, I mean, I would say, yes, noise, overlap in values and so on. And I really wonder if you use an algorithm steered I mean, a process which is steered by an algorithm to define classes of different features, how can it work out in such a way that it is repeatable? I mean, that you can repeat the same algorithm in the coming year or in another region, because normally, I mean, yeah, if you want, for example, you want to do a segmentation of different crop types, yeah, and then you get from the different channels, you get your values. So then you may find that a certain crop type have a range in one channel from A to C, and then the other one from B to D, and so on. But there is an overlap in the values, and how can you really, I mean, disseminate those different classes? That I wonder. So there was already an answer in the forum from Amy, where she says, yeah, it has a lot to do with resolution and so on. And I think as well, I really wonder how the people who are working with artificial intelligence, how, yeah, I mean, do they really believe that they can manage it at the end of the day? So I wonder, where do they see their own limitations? That is a bit my question.
It's true that working on the robustness of the model is something which is very important, and some way to do that is to work on the input and to try to use different calibration, as we say, on the data to add some noise. And this is some activity that, for example, we have for hyperspectral sensors, let's say on nanosat, because these data sets are very noisy, and each of the band can be well polluted, and at some point working on the robustness of the techniques and also on the uncertainties, I will say, on the prediction is something that is still an open question. And in terms of operationalization of the system, it's true that this is also an open field, saying that you have the DevOps. Maybe you know, it's a concept of having an update and a prototype, and at the same time, let's say the operational of the systems. And within the machine learning, we have now the MLOps, which is how you bridge the machine learning and the models up to the operationalization, and how you keep update actually the model depending on the data that you have now that may be different from the one that you train on. So this is a really hot topic, and there are some platforms now which are now prototyped that help people to really have flows for the deployment of ML systems up to the operationalization, which is crucial for sure.
Anna-Katrine, before we take other questions, you've talked about one challenge. Is one challenge it? Will you be planning other challenges? Do you have an idea of what those challenges will be?
Well, within this contract, we're planning at least 3 challenges. I have to say, the idea is also that the platform that we're building will also become a hub for other challenges for ESA if they want to implement any new challenges, that they can use this platform for the next decade. But within this contract, we're looking at 3 of them at least. So the first one is on air quality. The second one we're defining right now and will be related to food security.
Mm-hmm.
And the third one, we're looking then at emulation of data for VSAT2. It hasn't been finalized yet, the topics, but this is what we have in mind at the moment.
Simulation of data or test data?
So it's creating the potential data that could come from VSAT2.
So data simulation,
yeah.
Sort of training exercise. Okay. Okay, thanks. Amy is asking about limitations of the how to access data, the diversity of data, and we've also got a question about intergovernmental organizations. Amy, do you want to come in and pose and join the conversation?
Sure. My comment was more in response to somebody else's asking about limitations of machine learning or AI to remote sensing data. My question is mainly, I've observed that there's been a lot of adoption of Sentinel imagery for mainly agricultural tracking purposes, and that's the main area where I've seen applications for AI right now with regards to Sentinel. But there's usually a lot of academic work, and there's a lot of industrial startup work in this area around Sentinel. But coming from an intergovernmental organization, it's not quite as clear like what the opportunities are for better understanding how to get a hold of tools. I mean, there are many open source tools, but it's very interesting to see organizations like PhiLab working on this, and as it spins up, it's just of interest to know, if you're not building an application to sell, who's the right person to interact to discuss Sentinel and machine learning.
PhiLab is pretty open. Nicola, do you want to sort of give some advice there?
No, it's clearly at the PhiLab we are well concerned with this data ecosystem, which is required by the AI4EO committee, and it's true that we should provide the researcher industries and all the partners the data in the form required, and in order really to remove all the, let's say, the bottlenecks of the data preparation, training data, and so on. We have been developing in the past, for example, the Open SAR toolkit, which is a tool that helps to get analysis-ready data from Sentinel-1. We have also funded some project with a company which is synergized to ease the process, for example, with Sentinel-2, which is called EOLearn. So there are some tools existing helping people to get access to the data and prepare them so that it's ready to be ingested by AI model, let's say. But I know that there is a clear lack of maybe of communication on that, and we need to consider that. We need also to better train people, develop, do workshop, dedicated training, summer school or whatsoever, and more exchange on what's going on Earth observation data in general. So you might be aware that every year we organize the FEE Weeks, which is a large event that gather different partners. Last year, I think that there was more than 2,500 people connected because it was virtual.
Yeah.
So this is a good place for you to hear more and listen about the community, and yes, I recommend you to attend this kind of events and to be connected, let's say.
Okay.
Thank you.
Thanks. So, I mean, Amy, I think it's very open for anybody to learn. Monica, Daniela, you've put comments in the chat about EO4Geo. Let me know if you want to say anything, but in the meantime, I'm going to turn to Jeff Smith, and who's talking about again training data. Maybe the question's already been answered, but Jeff.
Hi everyone. Yeah, well, partially answered. I mean, it's more of a question of we're completely overrun by Earth observation data now, so that's not a problem in the process. And AI has the tools to deal with the throughput. But when we think of particularly the natural landscape, we're actually limited in some ways by our definition and understanding of some of the features we look at. We see plenty of examples of ships and aircraft, etc., being identified by AI, and they're quite, in some ways, simplistic features to identifying the imagery. But if we then think of certain habitats or even forest types, for instance, or forest itself, the definitions we use in various policies, different countries, even different people's understanding. Because when I say the word forest, everyone has an image appear in their head probably, and they were all extremely different. So if we then try and use AI for those things, the problem we run into is that the definitions, so it's not the AI itself, it's the definitions we're putting in through the training data that are problems. So I'm in favor of AI, but I need to make sure that training data is properly characterized, the definitions are understood and are flexible so that then people can use the outputs that come out at the end. Sorry, that was a bit of a rambling statement more than a question, but I'd like to know, are there efforts within the AI community to develop very flexible training databases to drive machine learning, and etc.? Thanks.
You used to rambling statements. I do it a lot myself. Who wants to comment?
Now, regarding the plane detection and aircraft, for sure. I mean, AI can be used for way more interesting application, and we were mentioning the super resolution, and I think this kind of application can be really be a game changer in the domain, because we need high resolution data, and if you need to buy them, it's maybe very, very expensive, especially for NGO, for example. So having some free solution and able to decipher some small objects based on this kind of techniques can be also useful. So really to push people to provide a new product and service using AI that really change the game is something that we are looking for, and not about detecting the plane or aircraft, which is obviously not that complicated. But this is something that we all need to work on.
There's a sort of related question from Ronan McAvoy, who's talking about resolution. We're onto object identification. I don't know if there's anything specific in AI, but Ronan, do you want to develop your question?
Yeah, hi everyone. It's just in terms of, I suppose, using remote sensing imagery and data to, in terms of object detection, resolution. It's been mentioned as a kind of limitation. I think, in here today and in other circles as well. And I suppose when you relate the two together, kind of a lot of the negatives seem to be focused on the EO side of things, and the resolution isn't good enough. Is there anything we can do to improve image quality? So I was just wondering, is there anything on the AI side of things that's kind of being developed or has been developed recently to kind of help deal with this?
Yeah, I mean, definitely the super resolution or downscaling, depending on where you're from, is another topic within the EO and also computer vision. And recently there have been many papers regarding, for example, the multi-frame super resolution. So you stack, for example, a series of medium resolution Sentinel-2 images, and you link that to very high resolution optical coming from Planet or Maxa or whatsoever Pleiad. And since you have a stack of images and multi-frame data information with different bands, then you can more or less create a very high resolution data up to the one that you are looking for. So there have been some examples in the literature, but what is missing for now is, again, to look at the robustness of that. These methods tend also to hallucinate, so they create some kind of fake artifacts. So in terms of usability for end users, let's say that you provide that information to NGO and they want to assess the damage after some disaster, then it might be an issue if there are some artifact in it. So at some point, we need to work on the trust on these algorithms and on the robustness as well.
Okay. Okay. I draw everyone's attention to the chat because there's answers to questions being put in the chat as well, and suggestions. So it's a good idea to follow that for everybody. We're sort of starting to come to the end of our time. Stefan has asked if he could say a few words. Stefan is with Space Tech with Anne-Catherine. Stefan, do you want to come in?
Yeah, yes, good afternoon. Well, yes, indeed, I support Anne-Catherine on the AI for EO project. And I wanted to say, because we are developing links and because we are kind of really looking at everything that is, or as much as possible to everything that is happening in the intersection between AI and EO, or even in AI that could become applicable for EO. We've not yet started to, let's say, offer a matchmaking kind of function, but I do believe that, and we will certainly make it clear on the website, but I think we're already in a position to start receiving queries on, like, I'd like to meet, or I'd like to enter into contact with people that do this kind of thing. We're starting to have a rather good overview. And if we don't know the answer ourselves, we have a few ideas, and we can, obviously the first one being our clients from the Phi Lab, but we have a few ideas of people we can reach out, kind of mini support, which we could definitely offer, either through again the Twitter, or through the functional email address that must be, if I remember correctly, hello@AI4EO. Members of ERSC or people participating to this discussion should not hesitate to contact us. And another comment I wanted to make is that there are, in fact, but they're just not publicized, sometimes, quite a number of operational industrial uses of AI within EO, quite a lot with VHR, because VHR does offer already a level of detail and resolution from which it makes it easy to extract features. I mean, I only learned recently that the European Maritime Safety Agency has a contract with a service provider that provides really very quickly after image acquisition, very high resolution images, in which already the type of ships have been, and there's like a lot of classes, whether it's a tanker, whether it's a passenger, whether it's a cruise ship, whether it's a yacht, whether it's a catamaran, a fishing trawler. I mean, with quite a level of granularity, and I think the image is delivered within half an hour. So it has to be machine learning at the beginning with maybe some visual inspection. There are things done that we find out by complete accident. I remember finding out several years ago already that a company in Belarus was delivering, like, operationally services to precision agriculture and crop type recognition based on Sentinel-2 and Sentinel-1 data. They were just not advertising where they were getting the data. But there are things already going on, and not only in agriculture, but in several other domains. And I'm pretty sure that in automatic extraction of floods from Sentinel-1, of hotspots from Sentinel-3 or Sentinel-2, etc., there is quite a lot of operational applications that are already either already working or in advanced prototype stage.
I mean, a lot of applications, but not necessarily using AI. Nicola touched on it earlier about models, and I wanted to explore it further, but I don't think we can today. But relationship between different models, different algorithms, and AI. So it's there are various degrees, I guess, of use of the technology. I'm going to give one last question, and then just close up. At the end, well, we'll come to that in a minute. Milad, I'll give you the floor to ask your question. milad.mahour.
Yes. Good afternoon, everyone. This is milad.mahour. I see one of the challenges nowadays we have with the AI. I mean, they are, of course, categorized in different groups, like what techniques or what AI techniques or machine learning techniques should be used for object detection, land cover, land classification, or even for downscaling from coarser to finer resolutions. But having all these techniques develops with lots of scientists, thanks to all of the research has been done. I see one big challenge here, and that is the big data. To handling such a big data, to be able to operationally develop an algorithm, AI algorithm for larger groups. For larger problems, we need to move on the cloud-based imageries. So there are two good examples in this perspective. One is the Google Cloud, and the front end is based on the Google Earth engine, and also Amazon. Both of them, they are American, and for example, we had a lot of problem with making Google Earth engine applicable for larger projects, but they do not follow up the GDPR regulations in Europe. And also we cannot also trust Google, because they are really good in shutting down their good services. This is what we have seen in the past. So that's my general concern nowadays, and I would like to bring it on the table. If you have any comments or feedback or solution on that, I would be really happy to hear about that. Thank you.
As has been answered in the chat, I mean, I think the idea of the DIAS was to try to provide a European solution to meet this issue. It doesn't mean to say that the American solutions are not good, they are. But as you say, there are other issues around the use of them, and linked to, you mentioned GDPR, but also linked to business models and sustainability. So maybe as Benedict says, maybe the DIAS is an answer. There are other solutions as well, so that could be a discussion. As was pointed out in the chat, there's a lot of interest in the subject, and maybe we should organise something more in the future. But I'm going to draw it to a close now. I give Anna-Katrine and Nicola just a last word to say anything. Anything further related to the project or linked activities, and then draw the cafe to a close. Anna-Katrine?
Okay, I just want to say thank you for the opportunity. I really hope that if there are any people interested, they can reach out to us at hello@ai4eo.eu, or of course register on the website, or attend any of the other webinars that have also been mentioned in the chat, from EO4Geo in March, or at IGARS, hopefully in person in July in Brussels.
You're very optimistic.
Yes.
Nicola?
Yes, thank you very much all for attending. I mean, this was a great event. I was very pleased to see all of you. And so please connect to this AI4EO.eu website and participate to this challenge. We really look forward to have many teams participating. And so yes, if you have any questions, please let us know. I mean, you can email, chat, or Facebook, Twitter, whatsoever. You have some way to reach us, so please do so.
We'll help pass on questions or answers as well if anyone wishes. Okay, thanks both of you. The next EO Cafe is in 2 weeks' time. We're going to be moving into a very much a user segment, looking at the mining and raw materials sector. As was pointed out earlier, this is also linked to an ESA project, but come and listen to what the challenges of the sector are and what could be the EO solutions. And then 2 weeks after that, we're going to be looking at the role of Earth observation in the Green Deal. We should have some guests to discuss. You've all heard of the Green Deal. You know it's a big policy initiative, but what can Earth observation do? How can Earth observation be introduced? So we hope to have some guests that can discuss that topic. I've also been asked to plug a meeting coming up, an ERSC meeting. I see the slide is about the industry survey. So again, please respond to the industry survey. But the plug is for the Connect.io meeting coming up in 2 weeks' time. This is the second webinar under Connect.io. The topic is the same. The first time it was held in Spanish, and this time it's in English, about business opportunities in Australia and Chile. So register for that if you're interested to join, and the registration address is there. So that's basically it for today. Everybody stay safe, have a good trip home, and see you in 2 weeks' time. Anyone who wants to stay, just even more informally, no agenda, no topics, but just to chat amongst yourselves, then please just stay online. And we normally have a few people just bantering away, but otherwise maybe see you next time.